Hello, and welcome to this Chemistry World webinar. Today's webinar is about digitalization and the future of formulating in modern R&D labs, and is sponsored by Uncountable. I'm Philip Broadwith, Chemistry World's business editor. Now, before we get started, I'm just going to go through a few of the features of GoToWebinar for those of you who might not be familiar. GoToWebinar is an interactive platform. You can ask questions at any point during the webinar, and we would really like you to ask questions as we go through. There's a box near the bottom of the GoToWebinar panel, which by default is on the right-hand side of your screen. You can type your questions any questions that you might have, and the questions, as I say, are really important. Please don't wait till the end of the webinar, because if we get all of the questions in at the end of the webinar, it's very difficult to make sure that we're answering them all. So, as questions occur to you, do drop them in that box there. We'll try and get through as many of them as we can. If you miss any part of the presentation, either if you have to leave or if you have some connection issues or anything like that, don't worry. We will be sending a recording to anyone who came or registered for the webinar in a few days' time by email. In that same email, to say thank you to for you to attend, to say thank you to you for attending the webinar live, then you'll also get a certificate of attendance. Today's webinar is about setting up the proper data infrastructure that's tailored to your business and overcoming some of the barriers that might get in the way of that. If we're talking about science-based businesses, you need to have the right data tools to make sure that they can streamline your operations, get the most out of big data sets. But that's kind of tricky. So today we're going to look at capturing structured data, how to do that successfully, the benefits that it can bring, and how that kind of works compared to more traditional lab notebooks, whether they're physical or electronic or various other ways of kind of capturing what goes on in a lab. For this webinar, we've worked with Uncountable to bring you hopefully some information that we think you'll be interested in from absolute experts in the field. Our speaker today is Will Tashman, who's one of the co-founders of Uncountable, and then later we'll be joined by Uncountable's chief executive and co-founder Noel Hollingsworth for the question and answer session. To make sure we can get through everything that we need to within the time, we've actually pre-recorded Will's presentation for today. I think we're more or less ready to go with that. So I'm going to let my colleague Chris cue the video up, and we'll hand over to Will just shortly.
Hello, everyone. Thank you very much for joining me here today at this webinar. I look forward to discussing digitalization and the future of formulating in modern R&D labs. For a bit of background, as you just might have heard, my name is Will Tashman. I'm one of the co-founders here at Uncountable. A little bit about Uncountable before we get into the agenda here. Uncountable is a startup based out of San Francisco, California. We provide a R&D platform to large chemical, material, biotech type companies. And this platform serves as a central repository of all experimental data, one that allows scientists to quickly and easily find any set of experimental data they would like, iterate directly in the platform, and then analyze the data in the same environment, with the goal of accelerating the R&D cycles that all the chemical companies in the world go through today. Our customer base includes a wide variety of different types of companies, from true deep chemical companies like a Cabot or a Xeon Chemical, who are making polymers or particles, to more formulators based, like a Bayer Paint or a Beiersdorf, all the way to more biotech focused companies like a Ripple Foods or even a St. Jude's Children's Hospital. So our customers range a wide variety of chemistry, application areas, technologies, types of customers, size, etc. And the reason we're able to support all of them is because we've developed a very flexible tool that's also very much tailored around the idea of promoting scientific data capture and ease of use for scientists. Now, a little bit about the agenda here before we get started and into the weeds. We're going to begin with outlining the problem at hand. And the problem at hand talks about how data what's difficult about data today in R&D environments, where the complexity comes from, And then we'll get into what tools are being used today to store this information and why that also creates its own challenges in terms of reproducibility, scalability, and truly shareable information in that regard. We'll then move into the notion of impact if you were to go from a more traditional tool like spreadsheets and lab notebooks to a more modern lab informatics type of platform that's really driven from the scientist up. And then we'll get into what the solution actually might look like. So we'll give actually a brief demo of the Uncountable platform to you. That'll be a short 3-4 minute video, but that will allow you all to see what we are talking about in the live and in the flesh. And obviously we can go and follow up with any questions from there. So if we think about what is challenging in the world of chemistry and chemical development, I think it comes down to this outlay over here. And so when we look at all of our customers, despite whether they make paints or makeup products or particles, the systems that they are all working with can somehow usually be divided into these different sections. So first is the quote unquote raw materials. So what really goes into the process? And these could be monomers, these could be byproducts or raw feeds, or they could be polymers, additives, etc. And they all have their own physical and chemical history. They all have their own batch relative, right? So you have this notion of what lot from what supplier had certain levels of performance, and they might have regulatory implications, cost or pricing implications. Maybe there's factors like particle size distribution or molecular weight or TG that affect their performance or why you're selecting them. And then you have your formulation. And that formulation could be a broad term here. Maybe it's more of a recipe, maybe it's more of a setup. This is the compositional information. This is where a lot of our customers are very unique and very skilled, and their expertise comes in, is how do we uniquely put these things together in a way that tries to achieve a certain level of performance. And this is complicated by the fact that there might be various stoichiometric constraints in place. There might be this sort of multi-layered or multi-step addition process, especially if you're in the synthesis area. Or maybe you have these sort of multi-layered bombs where you have one pre-mix or dispersion or pre-polymer that goes into a larger ecosystem, and that has its own formula or recipe itself. And then you transition into the processing. So this could be how you mix it, how you store it, how you dry it, how you cure it, or whatever it may be. All of that is obviously critical to the performance of certain materials like adhesives or coatings or paints or rubbers or anything like that. And then you have your outputs, your dependent variables, and these are your results. So these could be things like analytical measurements, GCs, FTIRs, DSC scans, or they could be more physical properties. Maybe it's a tensile or a viscosity or a pH or a gloss or something like that. And then you have maybe images, stability charts and reports. Maybe there's consumer panel testing. A wide variety of all these things you're capturing from how do we evaluate the performance of a new chemical or a new formula or a new material. And you'll note here that what we described in the past couple of minutes is actually that's just like one trial, one sample, etc. It needs all these pieces of information to really be fully described. And already this is a very complicated problem. How do you synthesize this information? How do you pull it together in an easily used way, both for searching or just visualizing and understanding what went into this process? Now imagine you're at even a medium-sized organization where you're running hundreds or thousands of trials or making thousands of new samples every month or every year. And you have 3 different labs across which you're doing this. And you have 2 or 3 or 4 or 10 different sort of chemical application areas, right? So maybe some companies have hot melt adhesives versus structural adhesives versus polyurethanes or PVCs. All of these create these sort of massively different data sets, but yet all things that need to be understood to truly manage R&D, to manage knowledge within chemical companies. And so the already complex problem of just one sample's worth of data becomes, orders of magnitude more complex when you really think about it from an organizational standpoint. Now, this next section here that we'll refer to covers a lot of the information around new systems, like new data tools, new, what we would think or what we would imagine the world converting to. But we'll start with what the old data is, right? Meaning, how do people store information today? How is this information circulated? What tools are they using? And we'll go into that sort of discrepancy there. But first, before we go and do that, we'd like to answer or have a quick poll circulated within the audience just to generate a baseline of current tools and understanding. And so with that, I'll pause and let the poll progress.
Okay, so yeah, as Will mentioned, we're about to have a poll. So Chris, if you could launch that. So the question is, if you needed to find the details of an experiment in your organization that matched certain criteria but was completed in a different lab, how long would that take? Are we talking less than 5 minutes, 5 to 30 minutes, up to an hour, or more than an hour, or the fact that you just don't think it would be possible at all? So we'll just leave that poll open for a little while to make sure that everybody can vote. And while you're doing that, it's a good time to remind you that once you've cast your vote, if you do have any questions during the course of the webinar, please just put them into the questions box as soon as you can. That will help us to prioritize the best questions to answer in the Q&A session towards the end of the presentation. The other thing to note is that just as a reminder, you will get a recording of the whole presentation in your email in a couple of days. So if you're having any problems with connections or not being able to see the video that we're playing out or anything like that, don't worry, you will get a full recording, which will include all of that in your email in a couple of days. So I think we're progressing fairly well with the vote. We'll just leave it open for a little bit longer. Another thing to note is that this is part of a series of Chemistry World webinars. So if you're interested in what else we are going to have coming up, then do take a look at chemistryworld.com/webinars on our website to see what see the subjects of other webinars coming up. Okay, so I think we've got to more or less as much voting as we're going to see. So we're going to close that poll and we'll see the results. So that's kind of interesting, I guess, but perhaps not unexpected. I guess that's the point of the webinar. There's not very many of you thinking that it's very quick to find the details of these other experiments. Quite a few in the sort of minutes to an hour kind of range, but the vast majority, almost half of you, over half, saying it would take more than an hour or it just wouldn't be possible at all. So I think that's a clear indication of the need for better technology, and hopefully that's what we're going to see in the rest of the presentation. So we'll just go to the next part of the presentation, and we'll hopefully shed some light on what we might be able to do to improve that kind of situation.
Now, if we progress here, right, part of the issue and the thing we're trying to identify and elucidate in that poll is the way data and information is stored currently. And so if we think about this from what tools are used today, I imagine many of these tools will look familiar to you, right? You probably are obviously starting with spreadsheets in some way, shape, or form. Almost every company we've ever seen uses spreadsheets in that capacity. But then those spreadsheets usually funnel into some sort of lab journal. That could be a paper-based journal, or it could be an electronic lab notebook, or and those typically are like the sort of source of truth for scientists today. Those might then themselves funnel into like a SharePoint or some sort of cloud repository for multiple people to view. But then you also have LIMS tools, so lab information management systems. These are usually reserved for analytical teams or teams that are very request and workflow heavy. You might have an inventory system that's used to capture chemical inventory. And then you might have sort of visualization and analysis tools. So what do you do with all this data that you've collected so far? And so the visualization and analysis tools obviously are there to help you understand data, look at data, better represent data for reporting and for lab journals and future context. You might have statistical tools, maybe a tool like JUMP or Minitab or Statis that you use today to look at statistical analysis and trends and variability and things like that. And some organizations have progressed to the point where they might even have predictive tools, where they have internal data scientists that are working on models that try and create a larger understanding there. And last but not least, you have this suite of internal tools. And internal databases and things like that, these could be things like your ERP. You maybe use SAP for that. It might be a regulatory system. Might be an internal pricing system. All of these obviously are critical tools, but usually ones that scientists have to go and access independently. So they're in their spreadsheet to formulate, but then when they go to look up a cost, they got to go into that system, pull that cost, put it into their spreadsheet. Their spreadsheet obviously isn't linked to that system. Same thing with like a regulatory status. We've heard stories of companies developing new products, new formulas, and then they get to something that's pretty good, and they realize it's not going to be regulatory compliant. And so they have to scrap this because of this raw material that they use, and they may have to sort of remove a lot of the benefit of the work that they've completed over the previous trials. And so, all of our customers use some, if not all of these tools in their current everyday aspect here. Now, what we see that is commonplace with all the tools that were described on the previous page is this notion of sort of unstructured versus structured data. So what do we mean by unstructured data? These are going to be a lot of the tools we referenced previously. So spreadsheets, lab journals, PDFs, SharePoints, Word documents, whatever those may be. These are things and tools where you can basically type in whatever you would like into the system. Now, the benefit of this is that you can type in whatever you'd like into the system. It has this unique level of flexibility. However, the drawbacks are pretty clear here. One is that there's virtually no scalability to these types of solutions, right? Every Excel doc is slightly different, most likely. And even if I use the same spreadsheet, all of my colleagues' spreadsheets are going to look different. So how do we sort of maintain that level of transferability and things like that is usually impossible. You also have a very limited sense of true searching, right? So yes, I can do a Control F keyword search, understood. But if I do a Control F keyword search for a certain resin, I might get 200 documents that reference that resin. Is that really that helpful, right? Like, don't you want a better way to really organize that information coming out of it? And so if we go to the other side of the chasm here, right, we go to what we call structured information or structured data. These are things like databases. They're things like LIMS tools, right? So maybe it's an inventory tool you have today. We'd also put Uncountable into this sort of structured information side. And the reason for switching to tools like this are very much around the idea of providing scientists and the users much better, cleaner access to information, right? All of a sudden, because everyone's on the same syntax, because everyone's using drop downs instead of free text, you need to be you're all of a sudden much more able to share information, to scale information, to transfer learnings and things like that. You also have this much improved ability to search on data. Imagine if you are a paint company or a rubber company and you want to find every formula that uses a certain ingredient and has viscosity in this range. Well, previously you wouldn't really be able to do that in any sort of spreadsheet system. But with these more structured environments, right, like an Uncountable tool or something like that, you're providing your team access to this information so you can really build off each other's going forward rather than this sort of potentially issue of reinventing the wheel. Now, the drawbacks for scenarios like this are pretty clear in that it's no longer this sort of free text field, right? I have a more purposeful sense of entry of data, right? I can no longer type in whatever I like in whatever shape or format or cell design that I want. It is now I am part of this larger ecosystem, and so I have to fit into the larger syntax, and that's obviously there's change management involved with that, but we'll obviously get into that in the next couple of slides here. Now, everything I've described on the previous slide, so structured versus unstructured data, you could theoretically use a lot of those same arguments and descriptors for normal business systems. So if you think about sales, right, they could theoretically use a spreadsheet and SharePoint, but they use CRMs, they use a Salesforce type of thing. Same thing with accounting or even operations or marketing. A lot of people could run sort of effective one-man, two-person type of systems via Excel. But once you get to true scale and you need to share information more readily, you often end up in these true systems. And so what's different and unique and special about what's in the chemistry environment, what's in these formulation systems, is this concept, are the following concepts, right? This is what makes this stuff in chemistry hard. First is this concept of noisy output, meaning if I measure pH today on a sample, and I go measure that exact same sample in 10 minutes or 30 minutes or an hour or a day, I'm going to get slightly different results most likely. And even if I use all the same equipment and try and remake the sample in a week or two, I'm most certainly going to get a slightly different set of results. And so no longer are you in this sort of absolute truth state per se, like where if you are an internet company and you want to know, what the price was at this exact time, there's sort of very, very clean standards there. Whereas in chemistry, right, the viscosity has noise to it. The gloss has noise to it. And so you need systems that are comfortable and understand that there's going to be noise in these types of environments. The second challenge, and what we've seen here, is this concept of multi-layered data, right? So many sort of spreadsheets are pretty flat, right? Here's a formula. Whereas in chemistry, right, I might have a premix, and I use that premix and I dilute it out, and then I put that dilution and premix into a full formula, and I might put that formula and layer it on top of 3 or 4 different formulas. Well, how do I get back to that original premix or that original dilution and trace that to the final, stack up properties? So these really detailed multi-layered nature of things creates challenges in terms of how do we actually store data? How do we search on this data? What do we use from a nomenclature standpoint? And then how do you effectively represent this data if you need to, use these sort of multi-layered bombs to search at the lower levels while maybe looking at the higher levels? The third challenge, and this can be very complex depending on your different systems, is this notion of different data types, right? Data in chemistry is not, again, not straightforward, right? So certainly, yes, pH is a pretty standard value, 1 to 14 kind of thing. But what if I have images? What if I have a categorical that is sort of good, bad, or ugly type of measurement or ranking? What if I have time series values? Maybe I want to record what the reactor sort of temperature was over time. That doesn't really fit into a little cell, right? It's these larger sets of information, these larger sets of data that all need to be tied together coherently and effectively, both from an analysis perspective, but also from a search perspective. And then last, but not least here, you have this concept of data sparsity. So data sparsity, we live in a physical world. Everyone in the chemistry space is doing physical trials, which means that it takes time, money, and a lot of resources to actually go and generate new data points. Again, this is not internet companies where you can run millions of experiments sort of digitally within a day. Everything, even running 5, 10 samples or whatever it may be, could take a day, could take a week's worth of preparation. And so in addition to having a lot of different dimensions and variables at play, you also have very few data points. So any system that is that you select and you want to use, you really should be thinking about how do we maximize those data points, right? Because this is such a resource intensive project, you need to be able to take what data you have and use it and extract as much utility as possible. versus, hey, if I need to rerun that simulation, I can rerun a simulation in 20 minutes and sample through that in different industries and different environments. Now, let's say you went to go and adopt this new system here, right? And you went from the old traditional lab notebooks, and you now have your head of your director of R&D or director of digitalization, and you want to transition your team to a collaborative ecosystem, collaborative system. What are the challenges you're going to face here in terms of adopting that system, right? So first and foremost is, what do you do with your old data? This is the age-old question, like everyone believes and is right in that there's a lot of valuable context and information in these previous spreadsheets, Word documents, lab journals, etc. But everyone stores data differently. Everyone stores data at a different level of quality and cleanliness. It might even be in literally different languages if you're an international team. Well, how do we make that cohesive and synthesizable in a certain way? And what do we do with that old data? Who's going to actually clean it up? How do we standardize it? That's obviously a key challenge here. The second thing here is this concept of, well, how do we integrate these tools with everything else? You don't want to create another isolated tool that doesn't link in with other tools and create that ecosystem, right? You want to be able to have your system link in with your ERP or your regulatory or your pricing or your process historians. And to do that is going to require IT resources and IT time. And that obviously creates a burden for them on where those resources are going to come, what the priority for those resources are, how quickly those will happen, and to make the system as vital as possible. The third thing here is, again, now that you have this system in place, you have so much more access to information in a good way, but it also creates access to a lot of information that people couldn't have easily had before. So how do you control who has access to this? How do you audit who is looking at the data or who is exporting the data? Could you limit exports? All of these things are now much more critical because you have the value in a small, easily accessible set of data is orders of magnitude higher than it was before you were using your bunch of spreadsheets. Someone would have to manually clean that. See issue number one here. And then last but not least is this concept of change management, right? So scientists they're all creatures of habit. Many of them have been working out of spreadsheets and lab journals for 10, 20, maybe even 30 years. How do you motivate them? How do you incentivize them? How do you actually train them to switch over to a system where instead of spreadsheets being the sort of currency or the lifeblood of the organization, you now actually have a collaborative system that promotes better data capture, promotes better information sharing within the same environment here. So if we look at this, right, and we've implemented our platform across a wide variety of companies, sizes, ages, shapes, and complexities, there's a couple of concepts here that seem to repeat themselves over and over again that usually lead to faster implementations and faster time to value. First is this concept of quick wins. And what do I mean by quick wins? Well, if we implement or introduce a system and we say, it won't do anything sort of really good for you for another year because of all the buildup, well, people aren't going to be very interested in that. And so you want to find ways within the first couple of weeks where something that they do frequently, commonly, all of a sudden becomes an order of magnitude faster. And those might be simple things, right? It might be performing a calculation or a normalization from a stoichiometric standpoint. It might be visualizing FTIR spectrum on top of each other. It might be making a report. It might be doing a search on your colleagues' data. Whatever those carrots on the end of the stick that you can provide to the users are very critical in that nature here. Second is this notion of prioritizing the future over the past. We've seen companies get very, very bogged down in the notion of like, what do we do with our old data? How do we fix it and clean it? And they spend so long trying to fix the old data that they ignore the future data problem. And so in 2 years, they might have a moderately more clean set of old data, but they still don't have a perfect or an improved way to collect data in the future. And so we often tell our customers, let's go and figure out if you were starting from scratch, what would you go and do? And what would be the best system to start from scratch on? And then you do your best to shoehorn all of the old data into that new preferred system. And in this way, data collected going forward is of the highest quality and desired outcome. And then you get what you can out of the old data when it comes, as opposed to delaying a much better current operating state from being put into place. And then the last thing here is making sure everyone is aware of this notion of it being a collaborative system, right? It is no longer are you in your own world where I can type in whatever I want, record data however I want, and make it basically only interpretable to myself. I now have this world where it's more about what information am I providing to my team. And so that means that you have a higher standard for data collection. And so you need to be able to reflect that in saying, you know, if I put a bunch of junk in, not only am I going to get junk out, all of my colleagues are going to get junk out. And so making sure that everyone's aware of this notion of garbage in, garbage out is critical for the success and the sort of shared responsibility of a new tool like this. Before we go much further, we want to talk about what does it mean to implement a system like this in terms of impact. What would you expect from an organization in the first couple of months of implementing a system? And what would you expect in the long term, right? 1, 2, 3 years down the line, how does this affect your overall organization? And so to dig into that a little bit here, think about from the short-term perspective. So again, three-month timeline, 6-month timeline type of thing. We've seen from internal polls and surveys, but also external polls like this McKinsey study, that scientists spend about a day to a day and a half a week managing data. So what does managing data mean? Managing could be cleaning, could be searching, organizing, actually doing analysis, generating, like creating these recipes. But of that day to day and a half, only about 20% of that is really spent analyzing and learning from the data. So you have almost a day's worth of time where scientists are basically playing data bookkeepers rather than thinking intuitively or chemically or intensively about the product or the chemistry that's happening or analyzing the information itself. And so with a tool like Uncountable or these more flexible systems, you're providing a much greater level of access to information, and you avoid a lot of that sort of bookkeeping time. So you cut out that time and you replace it with either more analytical thinking, more innovation level thinking. You also create situations where you can really understand, okay, well, what if my colleagues have already done something like this before? Am I really going to redo a very similar experiment just because I wasn't aware of the presence of that experiment before? Or can I avoid this sort of reinventing of the wheel concept that we see over and over again? The second thing here is obviously one that's unique to these times. Obviously during the coronavirus pandemic, not everyone is in the lab all the time, right? Your lab may be half staff or quarter staffed or 3/4 staffed or running on shifts. Well, how do you collaborate and share information in a way that makes sense and is effective to the organization? Like previously, we've seen companies manage where, okay, I put version 3 on a SharePoint or in an email, but that version 3 may not be my latest. And so if I update it and then my colleagues looking at version 3 and then they're looking at version 4, well, when does that get realigned? If I make changes in version 3, are we now in version 5? You see how those issues can arise when you're in this more siloed data environment. Well, within Uncountable, obviously you have this sort of instant access to information and it's instantly shared. And so with people in these more remote-based roles, you want that improved collaboration, improved communication devices in that regard. And then obviously for lab managers, right, most lab managers are tracking progress through sort of word of mouth, and then maybe they'll get a monthly or quarterly project report. Well, what if at any time I was a lab manager and I wanted to say, where are all my resources going? Who's testing what, how often, how is this project doing? How close is it to the end, or how close is it to getting a set of results that's good? Well, with that in mind, right, with a system like Uncountable, you'll be able to sort of track those resources effectively and change the way lab managers communicate and understand what their team's doing. Now, The other thing that's important to denote here is what happens in the long term. So when we talk about long term, again, we're thinking a year, 2 years, 3 years down the line. First and foremost is this notion that is about a knowledge management system. So many of the scientists that are in the organizations today might be closer to retirement than they are at the start of their careers. And so you don't want them either intentionally or unintentionally walking away with all this tribal knowledge, this expertise, without really being able to share it. And certainly, yes, they'll still have their lab notebooks. They might be in a cabinet or in a SharePoint, but because of those searchability issues we talked about earlier, I'm not, we've rarely seen scientists sort of lever up that results from maybe 2, 3, 4 years ago from some scientists they've never spoken to or never really heard of, and they don't have the ability to access or talk to going forward today. And so when we look at something like this, the most important thing we can do is capture that expertise so that when new, more junior scientists are brought on board, they are learning from the collective ecosystem much more effectively. They don't have to go and ask every scientist every single thing, do they have this data? And then they don't have to clean that data for themselves. They get this cohesive, same syntax type of information. And so they learn much more quickly, and they can start to solve much harder problems because the easier ones are already sort of greatly assisted by previous people's work. The second aspect here is about driving innovation, right? So everyone wants to, scientists rarely come to their desk and are excited about updating their Excel files or managing all those. What they want to do is think critically about the chemistry going on, the reactions and the stoichiometry and the functional groups and how those might combine. But if they are spending time playing that sort of data bookkeeper role, they lose some of that sight. And so if you can change the hours of bookkeeping into hours of more critical innovation type of thinking, you're much more likely for scientists who are the highest paid, usually assets within the company, to make the most of their time, give them the longest lever. And last but not least, it's always about delivering products to market faster, right? Everyone has customers. We have customers. You all have customers, and the goal of a good business is to deliver better products to your customers as quickly as possible. And so we want to help accelerate that development process for our customers so that they spend more time analyzing data, more time using the previous information to benefit future information than the more traditional, this spreadsheet, that spreadsheet type of world. Now, before we go much further, I'd like to make sure we give you a brief overview of what this system really looks like in practice. And so in the next couple of minutes here, we will show you a video of the Uncountable platform in action. And the video is going to move with a bit of pace. We don't want to sort of bore you with an 8 or 10-minute video. So it's about a 4-minute video. We're happy to answer any questions about functionality going forward at the end of this webinar here, or over email or whatever it may be. But we want to give you a sense of what is this new type of system? What does it mean to have structured data? What are the modules that a system like this should have? And so with that, I will again pause and we'll switch over to this video for your enjoyment. Talk to you soon.
Uncountable takes elements from traditional tools such as spreadsheets, laboratory information management systems, and electronic lab notebooks, and bundles them into a complete R&D software solution. Heterogeneous datasets are seamlessly connected within one system, making any and all information readily accessible through advanced search and filter tools. Scientists can easily input new data in Uncountable using recipe builders that are designed to manage all the complexities and nuances of a scientist's formulation work. Once the intended recipes have been created, a scientist can submit recipes directly to testing in a lab. Lab test requests can be managed directly from a central request management tool, where requests can be assigned directly to colleagues complete with status tracking, run sheets, and automatic notifications. In addition to the capturing of standard numeric text or image results, Uncountable supports custom uploaders that automatically transpose raw data files generated from measurement machines into curves or any relevant summary statistics that an R&D team deems as important, like tensile, rheology, or analytical data. Uncountable also provides a suite of visualizations for instant analysis and interpretation of the data. Correlation plots automatically surface quantifiable relationships in the data, which can be turned into learnings and sharings. As a scientist finds visualizations that are particularly interesting and help further their research, they can be saved and added to the project workbook. The project workbook functions like an electronic lab notebook where a scientist can collect their thoughts and observations as they progress towards their project goals. Uncountable also allows for the creation of custom reports that pull from any and all information inputted within the platform, and it is easily exported into a variety of different formats. With a wealth of properly structured data within Uncountable, the platform leverages powerful machine learning models to provide predictive tools to each scientist. Users can easily predict material properties given a set of ingredients and process parameters to get quick insight to see whether their changes are affecting key properties as expected. Even more advanced tooling enables custom ML models to utilize historical data to suggest experiments that are most suitable to reach a scientist's project goals. Unlike traditional experimental design tools, Uncountable promotes an iterative learning process and improves predictive accuracy with each data point. As with all statistical tools, the better the data, the better predictive insights. To deliver as much value as possible, Uncountable's platform is designed to promote easy and complete data capture. Uncountable is the complete enterprise software solution for R&D teams, helping them become more efficient and accelerate the development of new materials.
I hope that video was informative. And again, we recognize that there's some pace to it. We wanted to balance that with your own time and your own resources. And obviously, for more individual questions here, please feel free to follow up with us anytime. I think one thing you'll note here, and as you think about this decision and looking at other tools, I think one thing will become critical over and over again, which is this notion of fitting into a larger digital ecosystem, right? Everyone has digitalization goals and desires, but you don't want to, again, create more of these sort of disparate islands, isolated islands that aren't connected in any real way to other systems. And so for Uncountable, I think we view three or four main connections as being critical. So first is connecting to some sort of ERP type system, right? This is usually where production data is stored, usually where maybe some types of costs and bombs are typically captured as well. Creating a two-way environment there so that data from the production system gets to the development environment like Uncountable and vice versa, so that development data can be transferred into production environment easily is critical. Second thing is about regulatory. Often regulatory is usually a separately managed system due to its complexity, its changing notion, and the sort of nuance that is required to interpret some sort of regulatory changes. So being able to create a regulatory link for raw materials and formulas is really helpful and critical for many people who operate in the sort of consumer-facing world. We've also seen really good instances of process historian, process data coming into the working environment, right? So if you are running a synthesis reactor, if you're running a processing line, what if you could take all that time series data and link it up with a trial? Could you visualize that? Could you see if there were anomalies directly in the data, directly in the same place you're looking at your recipes and all of your other properties? This is obviously something that's immensely helpful. And again, connecting different sets of data, giving scientists access to that information as quickly as possible is the number one goal of a platform like Uncountable. And then last but not least is obviously the ability to capture measurements almost automatically, right? So scientists spend a lot of time just entering data. So if I run a tensile test, sometimes I have to print out that Excel file, print out the PDF. Maybe I take JPEGs or screenshots of the curves in the PDF. I put that into my lab notebook. I might take a copy of the summary table, put that into a spreadsheet, which I then put into my lab notebook. Rather than going through all those different steps, what we've typically done is try to create linkages to existing pieces of equipment. And so that once a trial is run on that, maybe it's a tensometer, or rheometer, or analytical piece of equipment, the user of that piece of equipment saves it to a shared folder. And then Uncountable can write scripts to pull from that shared folder and directly and automatically link it to experiments or samples in Uncountable. And so you actually, not only do you avoid scientists from manually typing data in at all, you actually create this system where you have much richer information, right? What if I have the full tensile curve, again, live, editable, viewable, searchable, comparable, rather than these static JPEGs or static images that you'd have to sort of eyeball and compare side by side. And obviously there's a bunch of old data to think about, and how do we get that in here from a sort of a transfer handoff type of standpoint. But we view connecting into a digital ecosystem, as long as data quality is not sacrificed, we want to be able to create those linkages, those bridges into different tools. Now, you've obviously heard a lot from me, but I wanted to give you a couple of just different examples of customers we work with. Some of these customers we've been with for 4 or 5 years now. And they've been able to realize these benefits that we talked about, in terms of, again, making scientists, enabling them to move faster, enabling them to be more critical and thinking about innovation in that regard. And then obviously you need to be able to, in the end, accelerate that development process and to solve these hard problems you're working on. So before we go too much further here, I think I'd like to just say thank you all for your time today. I know we've thrown a lot of information, maybe some potentially new terms at you, but we wanted to present this information in a condensed way, and then leave room for people to ask questions here going forward. So I'd say thank you all for your time, and looking forward to corresponding with you after any follow-ups.
Okay, well, thanks very much. That's Will's presentation there, and I'm delighted to say that we are now joined by Noel Hollingsworth, who is the Uncountable co-founder and also chief executive, and he's going to be here to answer some of your questions. Hi, Noel. Good to see you. We can see you okay. Can you hear us? And
hey, yep, Philip, great to join you.
Brilliant.
And sorry we didn't join the very end here, but I'm excited to answer any questions anyone might have.
Perfect. So we can see you and hear you, so that's all good. Okay, so we've got a few questions coming in, and I'm going to start with one from Shivani, which is, how can you give us a bit more information about how having structured data capture helps improve the quality of research? I mean, we've talked a little bit about, or Will has talked a little bit about the kind of how it all works, but how does that translate into improving the quality of the research?
How I really think about it is it helps collaboration. It helps collaboration across space. So if you're collaborating with someone in a different team who might be working in a different geography, it helps collaboration across time. So working with someone who comes in and looks at your work later, or even working at your future self. And it helps collaboration in a multi-step process. So if you're giving your results to someone else, how do they understand the data better? So as an example, imagine you're measuring viscosity today. You might measure viscosity, and there might be 5 different things about how you measure viscosity. There might be a temperature that you measure at, how much you age the material before you measure at, the RPM, the spindle you use, all those different things. If you're just putting that in a paper notebook today, maybe you just put viscosity down because you think okay, I did viscosity. But someone looking at it a year later and trying to understand, well, how does that match up with what my colleague did in another lab? If you were measuring at 23 degrees C and they were measuring at 0 degrees C, the results are going to be inconsistent, right? And there's going to be this reproduction problem. You're not going to understand really how they correlate without having this structured data. And the Uncountable system is designed so that you will be able to naturally fill that information in without it taking up too much of your time.
Okay, great. Yeah, that's a really good answer. The next question is from Friedrich, and this also kind of links into a question that I had. So Friedrich was asking about how the system handles chemical structures specifically, but I was thinking, there's a lot of information that is kind of requires a bit of chemical intuition, if you like, on the part of the software. So chemical properties like the hazards and risks associated with a particular ingredient. How does the system deal with those things, and is it kind of chemistry aware to link things together in that way?
The system is chemistry aware. We support chemical structures. We can extract things from SDSs such as hazard symbols. Based on the hazard symbols of final formulation, you can have the final hazard symbols displayed. It's not a replacement for a scientist with an expert in chemistry or an expert in computational chemistry, right? They're still the biggest experts here. But if there are core features that you think might correlate from those chemical structures to the final formulation, you can investigate that within the context of the software.
Okay, and does the system support multiple different formats for chemical structures, or do they have to be put in a particular way?
There's multiple different ones. There's our own drawer, and then there's importers available too.
Brilliant. Okay, and Friedrich had another question, which is, I guess, a little bit more technical, but kind of important when you've got when you're dealing with all of these kind of data systems. Is just thinking about where the servers are located. I'm guessing that part of that question is, is it always cloud-based, or can we have a local system or anything like that?
Yeah, so there's a lot of EU people on this call. So I wanted to bring this question up just because we do have servers in Frankfurt, Germany. So we are co-located in the EU as well as in Oregon, United States. In general, this is cloud-based, that we do think that is the way of the future. If there is something involving government or very highly secretive work that simply cannot be cloud-based, there are other discussions we can have, but pretty much all deployments are cloud-based.
Okay, that's great. And then I've got a couple of other questions. So obviously, Uncountable is not really the only provider in this kind of area. What would you say are the kind of key characteristics and criteria that you should go about evaluating what is the best solution for your needs as in terms of a data system?
What we would recommend doing is putting together an Excel sheet of how you currently work, of data that you would like the provider to be able to handle. And the biggest competitor is not Uncountable, it's not these other systems available, it's Excel. Excel is what everyone in the world uses, right? And so put together in Excel how you currently work. And if you're a value provider, give it to the provider and say, hey, sign an NDA with us, we'll give you this sheet, load it into your system and show us how this would work in your system. Show us entering data in the exact same way as we enter in Excel, show us searching for the data, show us visualizing the data. And see, is this an improvement over Excel? Can I use this to collaborate with someone else in the same manner? Because the thing that we have realized is, one, everyone is different and everyone believes they're different. Someone who works in glass says glass is harder than rubber, and rubber says rubber is harder than paints, is harder than foams, etc. And that's okay. There are unique challenges for each of these. And the second thing is, no one's going to believe it until they actually go and see it themselves, right? And seeing it with your own data is the most powerful.
Brilliant. Okay. Another question about kind of this. I mean, I guess as you've hinted, one of the most difficult things with this kind of thing is convincing people to change over. How much kind of IT professional time does this kind of implementation take up? Is it very difficult to do?
Yeah, so there's not much IT time for implementation itself of the base system. Typically, IT will want to be involved to answer questions like, how secure is this? Does this meet our standards? And then where IT will also want to be involved is integration. So an example within industrial labs is cost. Scientists usually want to know the cost of the ingredients so that they don't formulate something that they can't actually sell. That usually does not originate in Uncountable. That usually originates in like an ERP system like SAP. And so IT is necessarily involved to pull data from SAP and give it in a form presentable to Uncountable. And so much of that is dependent on how many integrations. Oftentimes it's possible to start with a deployment that does not have too many, has maybe a one-time pull at cost. So cost might be a little stale. And then over time you grow that.
Okay, That's really interesting. Okay, so we've got a question here from Kate, which is Uncountable just for chemistry labs, or would it work just as well for, say, a microbiology lab or in other subjects?
Yeah, so the context of the presentation today was chemistry, because of who we're speaking with, but we work across a wide variety of customers. So not only do we work in rubber, paints, inks, foams, polymer synthesis, we also work with St. Jude's Children's Hospital. We work with Ripple Foods, we work with Bayersdorf. So we also work with these biotech labs as well.
Okay, yeah, absolutely. So we've got a couple more questions here. One would be, so what's the difference between this kind of database solution and something that you could get off the shelf from Microsoft, like OneNote, or so? And you know, how does it being specific make it more useful?
Yeah, so OneNote is definitely better than doing things in a paper notebook, right? Having this auditable, searchable, at least ad hoc searchable method is much better than it's being stacked in a binder somewhere that you're never really seeing again, except for a legal proceeding. It lacks features that your scientists have probably created themselves in Excel. So it lacks, for instance, the ability to do stoichiometric calculations. It lacks the ability to understand, okay, what are these different ratios and how are they important to me? It lacks chemical structures and things specific to that information because it's not a chemistry specific tool, right? It'd be crazy if in the sales world, we asked everyone to work off of Microsoft Word, right? They get Salesforce, they get these different tools available to them. I think that's the goal of us and other providers to say, no, R&D deserves the same thing. You all deserve to be treated like first-class citizens too.
Yeah, absolutely. Okay, so I mean, obviously these things come with some associated cost. Can you give us a bit of an idea of what the sort of return on investment timeframe looks like, and that kind of thing? Maybe some examples from your customers.
The ROI really is that poll question that we asked. If you can find all of your data and understand it perfectly in under 5 minutes, you probably don't need a system like this. You're probably pretty happy with what you have today, right? Everything's at your fingertips. It's great. It's good to go. 47% people said it took them more than 1 hour to find something. And the reality of it is when it takes you more than 1 hour to find something, oftentimes you don't even look for it in the first place. And so what that means is customer A asks you for something today, you make it. Customer B asks you for something in a year, you go through the R&D process again. And that takes you 2 months. And maybe you lose the deal, you lose the customer because it took you 2 months when, wait a second, it was sitting on the shelf all along. And we've seen that across customers. That's especially important in the chemistry world where there's so many different acquisitions, there's so many different companies being joined together, where context is often lost. And so it's finding that data, it's analyzing that data in a much quicker manner. Our goal is that all of our customers are answering. It takes less than 5 minutes. It's all easy to do. And we have some case studies with Cooper Standard and Carbon talking about that in different industries.
Cool. Okay, and we have one more question from David, who is talking. I mean, you mentioned some stuff about regulatory compliance and that kind of thing. One of the that is obviously a big area. How does this system like this verify and validate the software to show that it is compliant, and can you prove that to the relevant regulatory authorities?
Yeah, so we're definitely designed with that in mind. When people use an ELN today, they often say, you know, I don't get much value from my ELN, but what I do get is I get a regulatory trail that lets me show off everything that the regulators or legal counsel is happy with. So we have those features as well. So those include audit logs. So you can say, okay, who has made changes to this formulation? When did they make those changes? We include locking and signing formulation. So you're done with the formulation, you can lock and say, I'm done with it. You can electronically sign it. We are compliant with the various regulations there, including FDA 21 CFR Part 11. It includes things like preventing exports of data. So if you have a team that cannot bring data out of the system, you can make sure they keep it in the system. And freezing data in time. So saying, okay, we cannot change this data moving forward. We need to be assured nothing changed past this time. There's also things available like regular backups for if you need to have that as something to keep.
Brilliant. Okay, well, I think that answers pretty much all of the questions, and I think we're just nicely out of time. So thanks again to Will for the presentation and to Noel for answering all of those questions. If you do have any further questions, then I'm sure if you want to get in touch with Noel or Will through the emails that we've just shared or are on the slide there, then please do. Thanks again to Uncountable for sponsoring this webinar. Without you guys, we wouldn't be able to run them. So that's all very important to carry on. There are a few links and URLs that we've sent out during the webinar. You may want to grab those before we finish. Otherwise, they will be in the details that we send out in a couple of days with the recording of the webinar. So you will get the full recording, and at the same time, you'll get your certificate of attendance if that's something that you need or want, which is great. And remember, if you like this webinar, do check out chemistryworld.com/webinars to see the other topics that we've got coming up. I hope to see you in another Chemistry World webinar soon. I'm Philip Broadworth. I'm Chemistry World's business editor, and we shall see you next time. Thanks very much for coming.